Hi, myself, Dr. Ganapathi Rao, working as a assistant professor in Institute of Aeronautical Engineering. Today, I'm going to discuss about the data models in DBMS. So, what is a data model? So, data models are used to define the structure, organization, and manipulation of the data in the DBMS. The data models which describe the data is how the data is stored and how it can be accessed and how the manage the data within the database system. So the data models can be classified into different types. There are approximately 9 different types of data models. They are conceptual data model, representation data model, physical data model. So these are the main types of the data model. These 3 are the main types of data models. And come to the additional data models are hierarchical data model, network data model, object oriented data model, float data model, context data model, semi-structured data model. So these are the 6 different types of data models. These are the additional data models. Basically, the data models are 3 types in the DBMS: conceptual data model, representation data model, physical data model. So these are the data models: conceptual, representation data model, physical data models. Now first we will discuss about the conceptual data model. Conceptual data model is a high-level model which represent the organization structure of the data. The conceptual model which represent the organizational structure of the data in the database. It focuses on what data entities can be exist and the relationship between them and make a relationship between them without having the detail how the data will be stored or implemented in the database. Mainly focus on these parameters. The main goal of the conceptual data model is capture the essential entities and make a relationship between in a system. Make a relationship in a system. So these are the conceptual data models. So in this entity relationship model, we simply call it as IARE model. So this is a high level data model which is used to define the data and make a relationship between the attributes in the data. So the entity model belongs to conceptual design of any database which is used to design the view of the data. So next model is representational data model. This representational data model is used to represents only logical part of the database. Does not represent the physical structure of the database. Only it represents the logical part, but not represent the physical part of the database. The representational data model allows to focus the primary on the design part of the database. In this, a popular representational model is a relational model. So in the relational model, basically which is used to tables to represent the data and make a relationship between the tables. So this is about the representational data model. So what now characteristics of representational data model? representational data models represents the logical structure of the database, which represent the logical structure of the database. So in this way, the relational models like relational algebra and relational calculus, these are used. And also use the tables. These tables represents the data and the relationships. So the representation model is a foundation for building the physical data model. Foundation for building the physical data model. So these are the characteristics of the representational data model. And come to the physical data model. Physical data model is used to practically implement the relational data model, which is used to practically implement the relational data model. So ultimately, the data can be stored in the database physically. The data which is stored in the database physically on a secondary storage devices like disks and the tapes. Disks and the tapes. So this storage is in the form of files. This storage is in the form of files, records, and certain other data structures. So this is about the physical data model. Simply the data can be stored in the database physically on secondary storage devices like disk and the tapes. So this data is stored in the form of files, records, and certain other data structures. And come to the some other data models. So some other data models are 6. In the first one is hierarchical model. Hierarchical model is one of the oldest data model in the data representations, which can be developed by IBM in 1950s. In a hierarchical data model, the data are viewed as a collection of tables, which is a collection of tables, and is simply we say it as a segments, and then form the hierarchical relation. So the data can be organized into tree-like structures in which each record consists of one parent record and many children's. One parent, each tree which consists of one parent record and many children's. And many children. This is happened in the hierarchical data model. So when you see the example for the hierarchical data model, so here we consider the cricket database system in a hierarchical model scheme. So here the player which consists of some children's, P position, P place, P birth date. So this is the hierarchical model of the cricket database. This is the example for the hierarchical data model. So next, network data model. So network of data model in which the data is organized as a graph with multiple parent-child relations. Simply it is called many-to-many relations, which uses the pointers to establish the connections. In this, we have to make the connections using the pointers. So what is the advantage of the network model? It is a more flexible than the hierarchical model for handling complex relationships. So simply the network model is a more flexible than hierarchical model for handling the complex relationships. See the example for the network model. In this example, level 0, which is the only owner of in this network, which consists the two level 2 and 3. This is the level 1. Level 1 consists so here commonly it has the number 5. So then it form the network. So this is the example for the network model. Next one, a relational data model. In relational data model, the data can be stored in the tables, in which the table consists the rows and the columns, in which we apply the some keys like primary key, foreign key to make a relationship between the attributes. See the example. Student is a relation. A student relation consists of three attributes: student ID, name, course ID. These are the three attributes. Here the data consists in the student ID 101, name is Ravi, is course ID course 101. So here student ID is the primary key. In next one, course ID and course name. Course ID and course name. So here the course ID is a 101, course name DBMS. Course ID is CSC 102 and course name is operating system. So here we apply the foreign key for this. So these are the example for the relational data model. Next one, object oriented data model. Data is represented as a objects. It's like a OOP. In this, OOPs also supports the encapsulations, inheritance and polymorphism in OOPs. Like that, the object-oriented data models also supports the encapsulation, inheritance and polymorphism. When you see the example for the object-oriented data model, a car is a one object which has some attributes like color, model, price. So what is the methods to develop? Here start and stop. So these are the example for the object-oriented data models. And come to the see the picture how we can represent the object-oriented data model. Example, see another example. So here in object-oriented data model, a person has the name is sit name. So in this name is another attribute student. For this person is belongs to, here student belongs to person. So here the student, doctor, engineer, these are comes under the person. So student is belongs to person, doctor is belongs to person, engineer is also belongs to person. Now here the student also has the roll number, branch and set marks. In this, doctor is a person which has the doctor ID, specialist and count operations, how many operations is doing. And engineer is also person. He has a engineer ID, department, count piece. So this is comes under the person. So this is example for the object-oriented data model. Next one, float data model. A float data model is not a commonly reorganized category of the data models. So we cannot use it frequently. So if you are referring the float point data types in databases, they are used to store decimals or real numbers with the precisions. When you use the float data model, they are used to store decimal or real number with a precisions. And come to the next, context data model. Context data model used to represent the data in which capture the context in the data used rather than just storing raw facts. For that, we use the context data model. So the context data model is used to understand how the data relates to different scenarios, environment and users. So this is about the context data models. So key aspects of context data model. So conceptual relationships, the data is connected based on the situation in which it is used. So data is connected based on the situation. For that we use the conceptual relationship. And also next concept, metadata driven. So this is one of the key aspect to use the metadata to define context like time, location, user or devices. And next one is the next aspect is dynamic adaptation. In dynamic adaptation, this model, conceptual model, can change based on different contexts, which is making it suitable for artificial intelligence, IoT, and real-time systems, for which we use this aspects. Next, multidimensional representations. So this is used to store data across multiple layers like spatial, temporal, and social dimensions, for which we use the multidimensional representations, in which we use in multidimensional representations. So this is about the conceptual data models, are simply key aspects of conceptual data models. So when you see the example of context data models, see the smart city data model, a smart traffic system which collects the real-time data from sensors, GPS devices, cameras. So here the sensor has some ID, sensor ID, location, vehicle count, time, weather. So these are the attributes. Sensor is the relation which consists the sensor ID, location, vehicle count, time, weather. So in this, the sensor ID is 101, where it is located junction A, vehicle, how many vehicles it count? 50 at the time 8:30 a.m. Weather is clear. And the same S102 sensor which is located at junction B, vehicle count is 70 at the time 8:30, which is weather is rainy. So what is the context here? The traffic conditions which is changed based on the location and time. At the same time, for a sensor, that location is weather is clear. The location is changed based on the location and time. Right. So what is the use case here? The traffic signal control. This is the use case. Traffic, adaptive traffic signal control. Next, examples of context data models. So in this, already we discussed this one, adaptive traffic signal model. Next, semi-structured data models. Semi-structured data models which deals the data in a flexible way. Some entities which have the extra attributes, some entities, some missing attributes. So in semi-structured data models, when you deal the data, in these entities have some additional extra attributes, some entities have the missing attributes. Finally, we can represent the data in flexible way. That is called the semi-structured data model. So what is the disadvantage of the data model? These are all the different types of the data models. Now we'll discuss the disadvantages of the data models. In the case of vast databases, sometimes it becomes difficult to understand the data model. It is difficult to understand some data models. That's why it is one of the disadvantages. So some data models must have the proper knowledge of SQL to use the physical models. So this is one of the disadvantages. So even smaller change can be made in the structure which requires the modification in the entire application. This is also disadvantage. And one more, there is a no set data manipulation language in the DBMS. To develop a data models, one should know physical data, stored characteristics. So these are the disadvantages of the data models. Come to the conclusions of the data models. Data models define how data can be structured, stored and managed in the DBMS. In this, we use the relational models. These relational models are widely used for structured data while NoSQL models handle flexibility and scalability. Flexibility and scalability. Come to the semi-structured models like JSON, XML, which supports the dynamic hierarchical data. Choosing the right model, which depends on application needs, scalability, and query performance. So this is about the conclusion of the data models. These are the references for these concepts, data models. So this is from database system concept written by Abraham Scratch and Henry F. Kurth. And second book is the Database Systems, Pearson Educations, written by Ramesh Elmasri Shamkant and B. Navate. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.